solving polynomial equations does not really add anything new to what you've been doing already with polynomial stuff. In fact, it makes things a little bit easier because a lot of times you don't have to factor completely to get solutions. So if we want to solve this equation here, it looks terrible, but it turns out to be really simple. Why? What can we do? Okay, good. We can factor out a greatest common factor. Let's get all the phone stuff away, please. I don't want to see any distractions here. Okay, so we can factor out an x to what? What power? An eighth, yeah. Factor out an x to the eighth. And if I do that, if I factor out an x to the eighth, what am I left with? Okay, and then by the zero product property, this is really simple. What are our solutions going to be then? If I set these equal to 0, what do I get here? 0, yeah. When is x to the eighth equal to 0? When x equals 0. Remember what we said about that. Anytime you have a greatest common factor, a monomial factor, that's, where it's just an x to a power maybe times a constant, you always get back the solution 0 for that, right? The 0 of some constant times x to a power is 0 every time. What about this one? What's our 0 going to be here? X equals 1. Those are my two. Then we got it. Okay, make sense? Yeah. Okay. All right, let's try another one. So how about something like this? Solve. Okay, if we're going to solve a polynomial equation, what's probably the first thing we got to do? Okay, we've got to get it into standard form. We've got to get it equal to 0, right? So I can subtract 4x, and we get 32x to the 4th minus 4x equals 0. Now what? Okay, we can take out a 4x here. Yes, ma'am.
Can't you split it into like 32x squared quantity squared?
You mean like, okay, maybe something like that. But here, that's not going to help us because I've got an x in this term also. See what I'm saying? So this is one where we would want to go ahead and factor out a 4x. And what am I left with if I do that? 8x cubed minus 1. Okay, so now what do we got? So we got two factors. One of them is done. We got this monomial factor that's done. We've got this other factor here that's a difference. Is it one of our, does it factor by one of our distance factoring, or our difference factoring patterns? Difference of cubes, yeah. Okay, so can we rewrite this then? Can we take this difference here and rewrite it as a difference of cubes? So we've got our, no, what is this thing? I never know. I think I need a new pen. This is on its last legs. So we've got our 4x times a difference of cubes. Now, what are the cubes? 2x, good. Everybody see that? 2 cubed is 8, x cubed is x cubed, and 1. So that's just going to follow our pattern where essentially this is A and that's B, right? Now what's our factoring pattern for a difference of cubes? A cubed minus B cubed factors into what? Good. A minus B times plus B squared. Good. Okay, so then this is going to factor into. So we get 4x times what? 2x minus 1 times what?
4x squared.
Okay, do we even care?
No.
Why don't we care?
Do they want us to do?
Because it's not going to give us a real solution anyway, is it? Now, we could factor this out, and if we did, we'd get, a squared would just be the quantity 2x squared, right? 2x times 2x, which would be 4x squared plus 2x times 1 plus 1 squared, but we don't even care. In fact, what you might even do is just call it q of x for quadratic of x or something, or just not even write anything there. Right? It doesn't matter, because when we set this whole thing equal to 0, remember that this one is always an irreducible quadratic with no real zeros every time. It's never going to be different. And so we know that we're not going to get any real solutions from that. Our only zeros are going to be from these two, where we get x equals 0 and x equals 1/2. Good. And in the future, next chapter, we're actually going to have ways of doing this. Like when we get to this point right here, we could solve this one next chapter by isolating x and taking cube roots. We just haven't done that yet. We don't know all the rules for taking roots other than square roots on both sides, but we're going to get that soon. So we'll even have a better way of dealing with that won't involve doing this factoring, although doing the factoring is not too bad. So we got our zeros, 0 and 1/2, and that's it. Okay, let's try another one. How about I know it'd be a good one to do. Oh, yes, we could. Okay, let's try. Gonna make one up. Just thought of a really good one we can do. So what we can do? Okay, move it all to one side. Good. Put it in standard form. Good. So I'm going to get, what, 29 x squared plus 35. Okay. Now what? Okay, now if we're just trying to get solutions to this, right? We're not trying to factor it. Trying to factor this would really not be very fun, because this would be an A times C then split B problem, wouldn't it? Right? But we haven't done that in a long time, because normally we're just trying to solve quadratic equations. What form is that, I guess, before I go any further? Okay, this is the thing we talked about the other day, where that's a quadratic form, isn't it? It's a quadratic form, only instead of it being quadratic in x, it's quadratic in x squared, right? Does that make sense? Because really, if we can just think of this as being 6 times something squared plus 29 times something plus 35, that's just quadratic. But what's my something? Yeah, it's 6 times what squared plus 29 times what plus 35. That's a quadratic pattern if we can just get something that to fill in the blanks that's equivalent to this statement above. Yeah, does everybody see that? That it's just x squared's there, right? So we would have done this problem in chapter 5, and those would have been x's instead of x squareds. How would you have done this problem in chapter 5 if you're trying to solve that equation? So what if this, say you're faced with this problem, some of you are still taking that test. What if we just had 6x squared plus 29x plus 35 equals 0? What do? I can't isolate x. There's two different, I have x squareds and x's. Quadratic formula, sure, right? We would just plug that in the quadratic formula, and we would get, if we did that, we would get x equals what? All over. Okay, and if we're only looking for real solutions, what would we probably do first here? Look at.
Discriminant.
Yeah, we would just look at the discriminant, wouldn't we? We'd just look at the part under the radical. Right? And what do you suppose is going to happen there? 29 squared minus 24 times 35.
No,
No
it's gonna be
solution.
That's, yeah, we could kind of finesse this out, but somebody real quick, get a calculator. What is 29 squared minus 24 times 35?
One.
It's positive 1.
One.
It is positive 1.
Yeah.
Okay.
9 squared is 8.
How about that?
4
So
times
it's
6 times 35 is 8.
so it's positive 1. How about that? So this one,
Did you make that up on your head, or did you?
I thought that. I tried to. I guess it worked. I don't know. We'll see. Are you sure you did that right? Okay, good. So that's this big ugly problem. That would have been really hard to factor, wouldn't it? Right? I like when things work. So that ends up just being the square root of 1, which is what?
1.
1. Okay, so we get the answers then. Negative 29 plus or minus 1 over 12, right? And we get 30 over 12, which reduces, negative 30 over 12, which reduces, or negative 28 over 12, which reduces, right? We're done. Now, this one over here makes it seemingly a little bit tougher, but not much, really, does it? Not horrible, because what do we get back for, I mean, what does the quadratic formula give us here? What's the only difference? Everything would look the same except one little part of this thing. Yeah, over here we ended up with, what's A, B, and C in this problem for the quadratic formula? 6, 29, 35. In this problem, what's A, B, and C for the quadratic formula? 6, 29, 35. The only difference is this, what it's equal to. Here it's equal to x, right?
So it'd be x squared.
Yeah, here it's just equal to x squared, right? So we're going to get back the answers. X squared equals negative 29 plus or minus 1 over 12.
So we just describe it again.
Yeah. And so what do we get for our answers? And well, we get two possibilities. Either we get x squared equals negative 30 over 12, or x squared equals negative 28 over 12.
So would that be simplified since there's an x squared, would you have to square root the other side?
You'd have to, because we're trying to solve for x, so we would have to square root. But what's going to happen this time when we solve for x? We're going to get i's, aren't we? Right? Now, if we wanted the i's, we got them. That's fine. If we actually want the solutions, all the solutions, well, here's, we're able to get them this way. Let's simplify this. So if x squared equals, what's that going to be? 6, so 5 halves? Just minus. Sorry. Minus 5 halves. So x is going to equal plus or minus the square root of 5 halves I, which we could simplify, but, right? And we could get the square root of 2 off the bottom. Let's not bother, right? What's this one going to give us over here? Or this would simplify to 7/3, negative 7/3. So x squared would equal negative 7/3. So if I square root both sides, aren't I just going to get x equals plus or minus the square root of 7/3 I?
So you could possibly have a negative I.
No, you can't have well, you can't, I mean, this is just, so if I wrote those all out separately, all this is the square root of 5/2 I minus the square root of 5/2 I, right? The square root of 7/3 I, or negative the square root of 7/3 I. And true, they're not all completely simplified. We could do that if we wanted to, right? So if we needed to have all the complex solutions, there they are. They're all complex, right? They're all imaginary. But let's just say here that we only wanted real solutions. When could we have bailed off the train? We did more work than we needed to, strictly speaking. Yeah, right. We could have bailed off the train right there. Because we can see right away that if x squared equals negative numbers, I know I'm getting i's. There's no sense even going any further. If I'm only looking for real solutions, what's my answer? N. No real solutions, right? So, get the idea? Okay, let's do maybe just one more quick one of those. How about, what if we had something like this? What if we had, like a little easier one. What if we had something like x to the 4th minus 2x squared minus 8 equals 0. What would we do there? What are we going to do there? What do you think? Jack, what are you going to do there? You got one like that.
I was thinking
We could.
the x squared.
We could write it in terms of x squareds. Good. So we're seeing this in terms of x squareds. So it's quadratic, right? Good. So we could just go quadratic formula. Do we have to? We can. It's going to work. But can we avoid having to do the quadratic formula, which is a little bit of a hassle? In other words, does this factor easily? Are there magic numbers? Yeah. What numbers multiply to negative 8 and add to negative 2? Negative 4, positive 2. Right? So we could break this one apart by simple factoring. So what's that going to look like then? What are my two factors going to be that breaks into? If my magic numbers are negative 4 and positive 2, tell me what to write. X squared minus 4 and x squared plus 2. Okay. So if we're only looking for real solutions then, what do I do? What are they?
2 plus or minus 2.
Plus or minus 2. Everybody see that? Because I'm solving the equation here. X squared minus 4 equals 0, which is when x squared equals 4, right? So I get back x equals plus or minus 2. What about this one? No real solutions. Because when I solve that, I'm going to get the answer x squared equals negative 2 i's, right? If x squared equals a negative number, I'm square rooting a negative, and I'm getting i's out of it. See what you get the idea? Okay? So this is easier, isn't it? I mean, these are easier. You don't have to do as much factoring on these because a lot of times you can just bail out of the factoring because you just want the solutions, right? Okay, how about, let's look at one more of these. I think you guys are probably okay to go on this. I'm only going to give you one assignment with this stuff on. Because really the factoring is the harder stuff. So you're going to get the, have I given you both factoring assignments yet? I think I have. If I haven't, I'll put the other one up. There'll be 2 factoring assignments. I'll only give you one assignment where you're solving equations, where you've got to do some factoring. But the part I want you to kind of realize and get some practice on is being smart about it. And kind of realizing, okay, well, I don't really need to do any factoring here. It's quadratic, I can do the quadratic formula, right? Do this in the easiest way you can. So think analytically. right? I'm doing overkill on the factoring, of course, a little bit, but you don't always have to do it. So how about something like this one? What if we had what are we gonna do? Yeah, think analytically. What's gonna be problem solving? I'm gonna solve this equation. What am I definitely gonna do first? Standard form. Good. Okay, now I want you to notice this is an equation. Now, if I were telling you that you had to factor this thing, what would you do next? I mean, I guess it's not. I mean, never mind. Forget I just said that. I don't think you make this point yet. Okay, you can factor out a 3x, can't you? There's a greatest common factor that you can pull out front. If I factor out a 3x, what am I left with?
X cubed. X squared. Negative
Minus 2. Okay, good. Okay, good. That's fine to do. Now, I want to make one small point though. It's not really a big deal in this problem, but in the future it will be in certain instances. Because I have an equation here, I'm able to always divide both sides of an equation by a number. That's fine to do. Okay, I can't divide both sides of an equation by a variable. So for example, I can't do this. People are sometimes tempted to say, okay, well, let's divide both sides by, let's see, 3x goes into all this stuff. Let's divide both sides by 3x. And if I did that, I would get back the equation x cubed plus x squared minus 2x minus 2 equals 0, right? Everybody agree? But what did I lose?
3x.
Yeah, I lost this 3x, and that's giving me a solution. That's going to give me the solution, x equals what? 0. I just lost a solution if I divide by a variable, right? But I could have, if I wanted to, I could have said, well, 3 goes into all those numbers.
But you can't divide.
And so I could divide both sides by 3, and I haven't lost anything. I just can't divide by a variable. If I had divided both sides by 3, that would have just been a fourth, that would have been a cube, that would have been a squared, and that would have been an x. That would have been fine. Then I would have ended up just factoring out an x instead of a 3x. But either way, whether that's an x, 3x, or an x, what's the solution going to be? 0 either way. Did you see my point there? Okay. It's not a big deal in this problem. It's just as easy to factor out a 3x as it is to divide by 3. So why not just do it this way? But sometimes that's really handy to do. Okay? All right, so continuing on. Now what do? We got the 3x taken care of. What about this other factor? It whittled it down to where it's smaller, which is good. But how many terms does it have? 4. So what's our strategy for dealing with a 4-term factor or with a polynomial? Yeah, that means grouping, doesn't it? Right? So I've got my 3x out front. Inside here, I've got my first group of x cubed plus x squared plus my second group of negative 2x minus 2, right? Okay, so lead me through the grouping then. We got the 3x out front, that's done. What am I going to get from my grouping? Okay, I can take out an x squared, that's my greatest common factor, leaving me with, okay, so then tell me what to write up here. Okay, I'm going to go ahead and write the template though, right?
Yeah.
Because I know And you guys are getting to the point where you can kind of think through this. You're smart. You can just think through this stuff all at once. But remember that really the way I proceed with this, especially if it gets harder and more confusing, is I need that leftover. And so the question is, does it work? It does this time. I could factor out a -2 to make that work. And so what does this thing factor into then? Well, what's this polynomial become? Now I can write it in fully factored form.
X minus 2.
Good, I've got my 3x. I've got my x plus 1 that I can factor out of the brackets, leaving me with, inside the brackets, just x squared plus -2, which is x squared minus 2.
Yeah. Yes. Possible.
And I just made those brackets so we could see where they came from. There could just be parentheses. And then this all equals 0. So now you can just tell me what my zeros are, right? What are they? What solution do I get from this?
0.
Okay, what do I get from this?
-1.
Okay, and do I get real solutions from that?
Yes.
Yeah, what do I get?
This is
Plus or minus, right? I'm going to get x squared equals 2, so x equals plus or minus square root of 2, right? Now, what if that had been x squared plus 2? Wouldn't have gotten any reals from that one. Okay? Make sense? We good? Isn't it kind of cool? Now, I mean, just think for a second here. Think where we came from this year. You should maybe start to get a sense that you actually know something now a little bit. Because you really haven't known very much. You knew stuff, but you didn't know very much stuff. I mean, you're getting to a point now where you're sort of becoming real mathematicians. I mean, you kind of know enough to really solve some major problems. You can synthesize a lot of different strategies. You can think analytically. You're getting much more powerful as math students, which is good. All right.